I'm so pleased to be here, and I should start now. Share the slide. I hope I'm doing okay. And as you know, my ability for this virtual conference, but I'm so glad I can talk to you. And so I have some conflict of interest. I have grants from several different places and also serve as advisory board for Amylyx and Mitsubishi Tanabe. So today's topics, I'd like to speak new diagnostic criteria and the PLS supplement to be published in 2020, and also PLS natural history studies, which should begin with this, a few grant support, including, of course, SPF. So already Frank told you that we had fantastic international meeting May last year, and we have more than 75 people attended, and we had funded by, of course, SPF, Mitsubishi Tanabe, NIH, and MNDA, and ALS Association, Biogen, and of course, Mr. Davis and family supported this meeting. We had a very fine dinner sessions, and a few people moved away after dinner before taking pictures, but this was a picture, and you can see Mr. Frank Davis in the front, and so that was really a great meeting. So we had the diagnostic criteria set 1992 and by Pringle, and also a little renewed by one of our colleagues, Dr. Gordon and Dr. Ron and myself, 2006. So they said we have to wait at least 3 to 4 years, and Gordon's criteria said 4 years. But waiting period is very difficult because concern is sometimes lower motor neuron sign developed and then becoming a little more ALS phenotype. And such diagnostic criteria limbo for 3-4 years. That means giving us a tremendous frustration for us to make diagnosis, and of course to patients who have this disease. So also I would like to show some picture, but everyone knows any neurodegenerative disease, not just the motor neuron disease, but including, of course, HSP, has a neurodegenerative condition, genetically determined or not genetically determined. Sooner, earlier treatment is provide a better opportunity to give good response. So I'd like to show you next slide. So anyway, we definitely need a better diagnosis, early diagnosis. So one of issues how to make early diagnosis, we needed to renew old diagnosis, which was 2006, and already 14 years or 15 years. So we decided to renew. Though Professor Turner took this work with committee members, and already paper was published in JNNP Journal of Neurological and Neurosurgery Psychiatry Journal, which is well-known, very important journal, published in this primary lateral sclerosis and consensus diagnostic criteria. So I'll tell you about the criteria. So patient has to be above 25 years old because juvenile PLS is known genetically determined by allosin mutation. So we are not talking about such a juvenile case, but older than 25. And the symptoms should be progressive with upper motor neuron dysfunction. That means muscle stiffness and reflexes very exaggerated, abnormal, and the pathological reflexes at least 2 years. And then no other symptoms such as sensory symptoms or active lower motor neuron sign. That means based on EMG, and minimum changes are acceptable, which is big debate, but we need to accept some minimum changes. And also alternative diagnosis based on neuroimaging or neurophysiology, that means EMG and transcranial magnetic stimulation. Other disease causing upper motor neuron dysfunction should be excluded. So diagnostic certainties from the onset to 2 years are still we cannot accept as PLS, because fairly high chance that those people may develop lower motor neuron, but beyond 2 years to 4 years are probable PLS. And beyond the 4 years, we accept a definite PLS. So this is a modified diagnostic criteria. Clearly, we can shorten up to 2 years after disease onset. But I think personally, I'm a part of this committee, made new diagnostic criteria. But personally, still, I have a problem what to do with less than 2 years. We are going to talk about later. So this was a tremendous progress after this conference. Now, also, Frank told you now about the PLS supplement. After the conference, we agreed, I think it's a little bit moved, but publish supplement. And you can see this diagram, and PLS and ALS, or mostly ALS combined, is about, in the past, more than 30,000 papers are published. But PLS specific papers, only 150 or so papers. That means probably 0.5%. So very minority of all those motor neuron diseases, specifically ALS, PLS. When you look at the PLS, most papers discussing neuroimaging and clinical issues, more than half. And then, of course, neurophysiology, genetics, and neuropathology, and cognitive issues are all described in those papers, about the 150s. So Biogen, and I think this slide somehow picture moved away, but Biogen and SPF fund this supplement. And I'm going to tell you, supplement is published towards the end of this year. And now we are final peer review process. Professor Turner and I, guest editor for this ALS and Frontotemporal Degeneration Journal, and we read every papers, but still we need outside people to review the paper. So we are now final review process, and after this review process, publisher will issue. And also during 1 year, they allow open access. So that means anyone can get the paper through internet. So the first paper is regarding clinical spectrum of primary lateral sclerosis. A lot of authors are here, and one of our key advisors, John Fink, is part of it. We described what is primary PLS's clinical presentation, but how we distinguish from ALS, how we distinguish from HSP. And Mills variant means only one side affected. And PLS is a rare disease, but rare disease presenting with just one side of the body affected, which called Mills variant or Mills syndrome. And also some proportion of patients develop some cognitive behavioral symptoms, and about the same frequency as seen in ALS, but that is also issues discussed in this clinical paper. And the second paper is Neurophysiological Features of Primary Lateral Sclerosis, and Professor Di Carvalho led this team and giving some upper motor neurons physiological issues, lower motor neuron dysfunction, and also peripheral central sensory tracts. And interestingly, a lot of progress in transcranial magnetic stimulations. And transcranial magnetic stimulation, if you can see me, put the device over the head, giving a strong magnetic field and excite motor neurons, and then motor neuron gives a signal through tract from upper motor neuron to lower motor neuron and contract muscles. So that's what we see in transcranial magnetic stimulation, tremendous progress in that field, how to measure, how to see functional electrophysiological integrity of upper motor neuron. But the PLS should not have lower motor neuron, therefore motor neuron dysfunction is clearly defined and limited in this paper. So next paper is neuroimaging. As you see at the beginning, neuroimaging is a majority of studies, about almost 30% of entire paper of PLS neuroimaging. Neuroimaging is tremendous progress in MRI and also PET scans. There are Professor Turner, and you're familiar with Sabrina Paganoni and Dr. Bide from Ireland has making tremendous progress in this field and describing that changes. So genetics of primary lateral sclerosis, next papers. We did the studies, 50 cases, but only when we did about 40 cases with gene analysis, about 5 cases we identified genetic cause. When we diagnosed with the primary lateral sclerosis, clinically not much difference, but genetic mutation was found, which is 2 ALS familial genes, 1 Parkinson's disease, and also 1 hereditary spastic paraplegia genes. So clearly, genetic mutation occurs in primary lateral sclerosis. That is described in this paper. Now, next paper is how to measure disease progressions. So we have to measure how we determine outcomes of if we do clinical trials. So we described the new PLS FRS. I'm going to talk about it in a few minutes, and the scale how we quantitate upper motor neuron dysfunction. We are making tremendous progress, particularly Mass General and University of Pennsylvania made good progress. And also how to measure, for example, walking and from sitting positions, stand up and walk, and 5 meters coming back and stand down, calling those up and go measurement. And those how to measure is very important. Therefore, we describe in this paper. So clearly a limitation and the future needs discussed in this paper. Next paper is clinical care and therapeutic trials. Dr. Warden was head of used to be head of neurology at Unifor Medical Schools. She's a neurologist, and she has a PLS, and she attended this meeting, and she wrote personalized care and very important issues because not many papers written about PLS. And also we talked about the therapeutic trials, how we do it. We have not done any clinical trials PLS, but we discussed if we do it, how we do it, what kind of clinical trials, how we do it, and what other possibilities we discussed. And then the next paper is neurobiology of PLS. Still, we have lots to learn, and after me, Dr. Handy is going to talk about the neurobiology of upper motor neuron, which is crucial, and we are developing. So Dr. Haase, Georg Haase took charge and talking about the biology of upper motor neuron in many different ways, experimental models and the mitochondrial changes and lipidomic changes. So we are now beginning of deal with biological changes in PLS. So the last paper is a neuropathology of primary lateral sclerosis, and Ian Mackenzie is such an expert in pathology, and and also experience with many cases of PLS. So he described those neuropathologies. So those are papers, and we are quite excited to publish towards the end of this year. So I would like to speak PLS natural history studies. So this studies, since this conference, I started organizing this natural history studies. And as you know, without a grant, without money, we cannot do any research. So I've been talking to of course, SPF and Mitsubishi Tanabe, and ALS Association, and they all agreed to support this important studies. So we have now funds, which is still born and actually really minimum amount, but we are now able to start this important studies. So this is a busy slide, I apologize, but why do we need natural histories? Natural history means if there is no specific treatment then we followed how disease progress, what's the variability, the progressions, and so forth is natural histories. If treatment becomes available, technically speaking, ALS, you cannot get the natural histories because most patients taking Riluzole or Edarabon, so those are treated. But at this point, there is no specific treatment for PLS. I am talking about disease-modifying treatment. That means the cause of disease mechanism change with medication. We're not talking about the medication to ease up stiffness of the muscles or pains. Those are not disease-modifying treatment. Those are symptomatic treatment. Therefore, I think we have still a chance to see how disease progress. We ourselves conducted 50 PLS patient and disease 5 years or more after disease we call definite PLS. And again, we are not talking about the new diagnostic criteria. This is based on old diagnostic criteria. And we thought we should study on the PLS patient with a definite diagnosis. And so that was a prospective studies. We published many papers. Now, Dr. Floater, I'm sure you're familiar. She used to be head of NINDS clinical division, and she published studies, 50 patient prospective studies called PLS ascending, PLS multifocal, and PLS Pulver, and then she studied those studies divided, and her conclusions of progression is not all everyone steady, and sometimes disease progression stops and then progress, kind of things she described. But most studies are retrospective studies. That means when we decide to study, we back to in the past, collecting 100 cases or 50 cases, look at how patient progressed. But those retrospective studies are biased because how we make diagnosis sometimes depending on how physician make diagnosis and where we collected limited centers. Therefore, a lot of biases involved. So we have to prospectively make the plan and collect and study patient. Natural history of early PLS. Early PLS means probably less than 2 years or less than 4 years, never been properly investigated, which is critically important. And also now we have new tools. We have PLS-FRS developed. And so we have other means to measure clinical progressions. So based on those tools, we can study a patient disease progression prospectively. The natural history studies is so essential and critical to make, plan, design future clinical trials. And so that's the reason we doing this, because the PLS has never been included in clinical trials in ALS. So in fact, no clinical trials ever done for PLS, for disease-modifying clinical trials. Therefore, this natural history data provide very important data. Now we have a potential medication available, and we talk about a little bit later, but I think when we have natural history data, we can moving to those directions. So this is the picture I'd like to show you. This is a slide made for ALS, but most people think PLS is extreme end of PLS, ALS spectrum. And so ALS and PLS might be same disease mechanism, but end of spectrum. So for ALS, disease begins much earlier, even time of conception or early ages, early baby stage or child stage. A lot of course, genetic factors, also environmental factors, and those process ongoing slowly until motor neuron cannot live anymore because of these negative impact, and then gradually, slowly symptom occurs. PLS is much slow pace, but we know disease being much earlier. So everyone believes treatment begins early. That's provide best result. So this is a repetition, but everyone agrees if we have a treatment, has to be early. So just we just went through everything. So now we have ALS, PLS, ALS, FRS-R. This is most common disease scale for ALS, ALS-FRS revised R. And this is 12 scales. Total score is 48. And each score, initially 3 bulbar symptoms such as speech and saliva and swallowing. And the next 3 subscale questions are dealing with skilled hand function. And then next 3 are dealing with gross motor, means turning in the bed, walking and climbing stairs. And last 3 questions are dealing with breathing. This shortness of breath. Orthopnea means just cannot lie down on back because of breathing difficulties, and using some respiratory inefficiency using a device such as BiPAP and so forth. Those are ALS-FRS-R. This scale, if you talk to ALS expert, any clinic, ALS clinic, any clinical trials, and not the United States, everywhere in the world, it's most commonly highly validated used scale. Now there is a problem. I'd like to show the slide, the busy slide, but I want you to pay attention. So this is a PLS, FRS, PLS 1 year, second year, based on our earlier studies, and comparing with the ALS Cosmos studies, 355 patients. And then I want you to pay attention this ALS-FRS-R. When you look at ALS patient scale moves 1.4 per month. And so disease moving fair speed. You can detect the changes in 6 months and 12 months, big changes, total of 48. So disease moving fast in ALS. However, PLS moves so slow. So if you look at ALS-FRS, really moving at a very slow pace. First year and the second year slightly getting a little bit more, but essentially changes are so small. And if we use ALS-FRS, very difficult to detect changes in case of a PLS. You can see many different ways, for example, breathing test, and finger tapping, foot tapping, and all those changes are very slow in PLS compared to ALS. So this is the most widely used scale, but we may not use in PLS. So we needed to have a little bit more sensitive scale, specifically detecting changes in PLS. So that's what we decided to develop new scale or modified scale called PLS-FRS. We put additional points between ALS-FRS between 4 and 3 and 3 and 2, up to gross motor scale 9, and the breathing very change in patients. So we did not change anything from ALS-FRS. So based on PLS-FRS, made a new scale like this, total of 48 point, and best is normal 6, 0 is no function, all those same thing, speech, swallowing, and salivations, and fine motor skill, and gross motor skill, and then breathing again. Breathing is did not change last two things, but also we changed the dizziness scale as well. So conversion is made this way, and when we took PLS-FRS, we can convert to ALS-FRS just conversion. So we can still look at potential ALS-FRS if we use potential as how it could be. So that's the conversion scale. So we did this studies again, help with SPF, and this is the total scale, 77 patients, and we studied changes. When you look at this 6 months and 12 months, clearly a tiny bit of change, tiny bit of difference, but PLS-FRS is better than ALS-FRS significantly compare between these scales. And again, total scales steadily moving. This red is PLS-FRS, and green is still moving, but the slower pace. So we're happy even if you use this PLS-FRS, 6 months is possible to detect the changes. And then we had only 10 cases of early PLS, it's less than 2 years. And again, changes are very small, initial 6 months, but after 6 months to 12 months, changes have become much faster in PLS-FRS compared to ALS-FRS. So again, we're encouraged to use this PLS-FRS. I hope you are taking okay, but now, based on those tools we have, we decided to do international PLS natural history studies. Currently, only United States. So we've had the funding from those 3 organizations, and U.S. Studies and Columbia University is our center organizing project. But we use NEOS, MGH, Massachusetts General Hospital, Alex Sherman organized data management neurobank. And so they have tremendous experience and data collection and also distributing whoever wants to have data. That's what, and everyone wants to have data dissemination, and also biorepository at Columbia. Dr. Santella is organizing biorepository. So Dr. Ken Chang is a professor of biostatistics at Maryland School of Public Health, is organizing and analyzing data. And we analyze result and publish when we finish. It takes probably 2 to 3 years, but as soon as we finish this data, we can go to next clinical trials based on this data. Now, we have been talking to a British MNDA, and PLS FRS is English-based. We developed English. Therefore, we are looking at English-speaking people, England, Ireland, when they are interested in, they are delayed, but we're doing the same studies and more case. And of course, also Australia and PACTAL, this is a Pan-Asian Consortium of Treatment of ALS, and this is Australia, Japan, China, all those Asian study group now organized, and Australian Dr. Matthew is interested in organizing Australian studies. So probably they're supposed to meet in September, but because of the corona virus, that's meeting postponed until next year. But again, they're interested in organizing. I spoke with one of the Quebec neurologists. They are interested in developing French version of PLS-FRS. So now PLS-FRS becoming a little bit more international, and the study will be international. Why? Because PLS is so rare, and get needed number of patients to be studied, we need a larger number of study sites. For example, when we did PLS-FRS studies, we had 20 centers, just listed 1 to 20, but we included more Canadian site, more newer site in United States. So now we have 27 centers. All those sites are major investigating clinical trial site. So you can look at the University of Kansas, Texas Neurology. Dr. Heitzman is so many years working with me, and Mayo Clinic, Minnesota, and University of Michigan, Beth Israel, Mass General, Temple University, Johns Hopkins, University of Minnesota, Emory University, UPenn, UC Davis, Mayo Clinic, Cleveland Clinic, Penn State, University of South Carolina, she's new, joining, Ohio State, University of Nebraska, St. Louis University, Columbia University, NOWS, University of California, Irvine, and NINDS. Justin Kwan succeeded Dr. Floater as a head of clinical division of NINDS. And also Kristen Shoesmith is Western University, London, Ontario, University of Calgary, University of Edmonton, McGill University. So major universities, clinical centers are involved with this clinical trials. Clinical natural history study, excuse me. So what do you do? So this is 12 months, and we hope 12 4 months, we check minimum items. So at least we know 24 months disease progression. We still need to raise funds, but eligibility assessment, and we, of course, consent form signed, we do examination, and then cognitive testing is very important because probably a few percent, and based on the test itself, maybe a greater proportion of patients may have some frontotemporal cognitive impairment. It does not interfere daily life, but when you test, we find some changes. And what they're using, equipment, the medications. We review all those equipment, and then we have a Penn upper motor neuron scale, and Dr. Lauren developed quantitative upper motor neuron scale. This has to be examined by per patient, so we included this as baseline, and then 6 months, 12 months. Those are visit. Baseline, 6 months, 12 months, patient has to come to the center to be examined. And PLS-FRS is 0, baseline 3, 6, 9, 12 months. Now we have a pataka. Pataka means bulbar function, means pataka, pataka, pataka. As fast as you can do pataka, pataka, pataka. So how many times you can count in 10 seconds. Also, I hope you can see me, finger and foot tapping, finger tapping. Can you see me finger tapping? If you have spasticity or muscle stiffness, this movement is very slow, regular but slow. So you can measure how significant those upper motor neuron signs, finger tapping and foot tapping, foot tapping. So those can be done using smartphones. Patient doesn't have to come to the centers, and also quality of life scale, and the time up and go, just I briefly told, in a sitting position, go, patient stand and walk 5 meters and coming back and sit down. This is a test, but has to be done in a center. Certainly we can do over the phone, but certainly we don't want to take a chance. We don't want to create any falling and so forth. So this time up and go test is very common, well-known studies can be done baseline, 6 months, 9 months. And then of course we collect DNA, blood samples, urine samples, and EMG is done at the end of 12 months. So at least we know how disease, particularly lower motor neuron changes. This is a simple, I would say, simple but sufficient to collect natural history data, and probably in future clinical trials, Penn upper motor scale, and those measurement, how to measure disease progression becoming critical when we start using potential medication. So I'd like to move on biomarkers, clinical data. Now we have genes, and we are going to hear today very exciting genetic issues, but genes are very important. We have to include how often genetic modification, genetic mutations. Gene can tell disease progressions. So that is very important. Next one is skin fibroblast. We studied earlier studies, mitochondrial abnormalities. When you compare mitochondrial abnormalities, PLS is more abnormal than ALS. The high oxidative, high metabolism going in skin fibroblast. Of course, question is skin fibroblast represent brain neurons. Of course, we cannot say, but if nerve cells or any cells are representing our body, and skin fibroblast, when it's driving the patient's skin, representing the changes which occurs in the body. Therefore, mitochondrial changes are quite abnormal compared to ALS. PLS is far more abnormal. Also, lipidomics means we measure lipid changes. When you look at what kind of lipid in the blood, about 250, more than 250 species, different type of lipids in the blood circulating. So we can measure what's a proportion lipid, and cholesterol ester, and many cholesterol is a very common terminology, but that's one only lipid, very high amount, but very tiny lipids are there. We don't know what they're doing, but must be very important function, so we can measure amount and distribution of those lipids. Again, PLS has abnormality compared to healthy people, and more significant changes in ALS. So we know mitochondria and lipid are different in ALS. We did not study neurofilament in PLS, but the neurofilaments are abnormal in PLS because neurofilament representing when neuron dies, neurofilament comes out because it cannot retain cells. So must be abnormal, excuse me, but we have not done. We need to look at in the future. The urine is clearly abnormal. I'm going to talk to shortly, so those are early biomarkers in PLS. So we do biorepositories, DNA, plasma, urine, and for future studies, anyone come up very important studies, we can provide 100 patients plasma and DNA or urine sample, they can measure, they can help you. So biorepository is very important. And of course, natural history data is very important. Some drug company wants to develop new medications and how patient develop, we can provide completely de-identified the patient name, and all those critical information are not there, but we can provide as a patient history, progressions, they can use those data to develop new medications, specifically PLS in the future. So urinary biomarkers are very interesting. And I would say a patient with PLS is clearly abnormal in oxidative stress. So isoprostane is lipid peroxidase product, means lipid oxidized by oxidative stress and lipid becoming abnormal structures. We can call isoprostane. 8-oxo-deoxyguanosines are DNA adduct. DNA also damaged by free radicals. And those damaged free radicals we can measure. But these are relatively recent events, probably less than a few days and so forth. We cannot measure long distance, long past oxidative stress at the moment. We don't have any such technique. But when you measure those isoprostane in the urine, patient is clearly abnormal, highly abnormal compared to control group. Rest control is we did study national ALS registries, and based on those we have controls. So to compare to those control group, which is prepared for ALS, but we can use as a control. So there's a clearly different, but not in 8-oxo-deoxyguanosine, but very close to the significance 0.05, I must point out. So when you look at comparing, there's a two group of controls. One is sibling controls, the other one is population controls. Population controls, age, sex, and residential area matched controls for the patient who have ALS. And again, both sibling controls and population controls, isoprostane is abnormal, significantly abnormal compared to both population, but not 8-oxo-deoxyguanosine, although sibling controls give some close to the control, but not the population controls. But when you compare siblings and population control themselves, they are not all different. It's the same group. So in terms of sex and age, PLS and arrested siblings, age and sex is no difference, but arrested control population controls clearly age is older than a PLS patient population there. So we did not collect controls from the PLS. We used controls prepared for ALS. That may be the reason why we see the difference. Yet gives some idea PLS has increased oxidative stress. So what's the potential medications? Is any medication available? For example, Briuzol never studies in PLS. Edaravone we have been using now a few years, never studies PLS. No one take PLS, such expensive medication. Insurance would not cover, and because we don't know whether it works or not. And tremendous clinical trial going on PLS. Now it's slowed down because of COVID, but gradually catching up. A lot of clinical trials on the horizon, and platform trials are started from Mass General. Platform means several different medications simultaneously test by different site. So one placebo group, let's say 50 placebo group, but 50 patient with A medication, 50 patient on B medication, and currently only 2 medication, but in the future, much larger scale of platform trial can be done, efficient. Why efficiency is needed? Because we have to decrease number of controls who takes placebo. And best clinical trials test without a placebo, but we never prove medication really works without a placebo. But we can conserve number of patients who takes a placebo. So platform clinical trials are effective. That trial is ongoing. And then Amylyx medications are very exciting. We don't know what's happening, but again, this is mitochondrial medication that might help for PLS. Methylcobalamin called cobalamin. Methylcobalamin is studied in Japan. They finished the second stage studies, and I heard that was positive. We have not heard the formal announcement, but what I'm telling you, these are ALS medications. Now, in the ALS medication, we want to try patients with PLS, but we can't because the insurance would not cover, very expensive, and we don't know works or not. So I think it's a very important those medication works for PLS or not. That's the first easiest question we have to answer. I would like to tell you we had tremendous support from SPF Foundation. We did a prospective study of definite PLS funded by SPF, but also MD Wings, other centers, Mr. Marin, and Adams Foundation. We did these large studies. Part of ALS, we studied PLS. And PLS-FRS was developed based on, again, support of SPF grant. And then international conference last year was supported by SPF, but other organization, and tremendous actually generating interest and doing many different things, as you already know, we described. And now we have PLS natural history studies, again, supported 3 organizations, including SPF. And I think this is a critical step to clinical trials. So this is the last slide. And I think we are making enormous progress in PLS because now we have a PLS-FRS specific scale developed. We have now a new diagnostic criteria, and early biomarker has been developed, and new conference supplement is being published. So much more on PLS. So now PLS natural history studies, we would like to study early PLS. Diagnostic criteria, you have to 2 years. To me personally, this is my
hurry up. Why does it have to take so long?
personal opinion is 2 years waiting long. 2 years waiting period is too long, so we needed to shorten up. We studied even before 2 years, and we have to see early and definite PLS disease progression, 50 patient early, 50 patient definite. And also we look at the genetic background, urinary biomarkers, and we have now new diagnostic criteria just published this February, but based on natural history, how this new diagnostic criteria is accurate. We can validate new diagnostic criteria based on natural history studies. Also, as I said, this natural history study is critically important. We can talk about two clinical trials. One is randomized placebo-controlled clinical trials, which is standard, gold standard clinical trials. But when we see medication works or not, you can do natural history based clinical trials. So our natural history data can be used as historical control. So every patient can take medication to compare historical controls. But the problem is we do natural historical control based clinical trials. We can demonstrate medication works or not, but FDA will not take to approve a medication as a treatment for PLS. So that's still, we have to work with the FDA if historical control based natural history study clinical trials is good enough or not. But again, to do standard, gold standard, placebo-controlled study would be very difficult to collect the patient and so forth. So we still need to work a lot of issues, but we are moving in the right directions. So I think now PLS has been neglected, rare, and just don't know what's going on. But I think our steady work with everyone else, we can move to the next stage. So thank you very much. Again, we had really continuous support from SPF, and we can do clinical studies, and really thank you very much. So I'm sure you have some questions, and I'm happy to answer in later through email or whatever Norma suggests me. I'm happy to do that. Again, thank you very much.